Hi friends, Miss A here. Today we're going to talk about Module 5, Lesson 20 and 21. So we're first going to start with Lesson 20, and we are going to recognize and show that equivalent fractions have the same size, though not necessarily the same shape. So again, make sure you are listening to this whole video for our secret code word, and then you will tell your teacher at the very end. So let's get started with our equivalent fractions. So we know that equivalent fractions have the same size and amount, but they are not necessarily the same shape. So let's kind of dig in and see what is there. So the whole is all of the cubes. So the whole is all these cubes put together. So whisper to your screen, what fraction of the cubes are blue? So take a moment, whisper to your screen, what fraction is blue? Great, 1/4. Again, this whole is all of the cubes combined. So this is one whole right here. Now, again, whisper to your screen, what fraction is blue? If you said 1/4, great. So let's move this up. So I want you to stop and think, are the fractions of the cubes that are blue in both of these pictures equal, even though the models aren't the same shape? Think about, is this equal to this? They have two different shapes, but they have the same fraction. So we know that the size of the unit and the size of the whole didn't change. So each block, we're using these blocks. So each block is the same. So the size didn't change because we have 4 blocks over here and we have 4 blocks over here. That means that they are both 1/4, and that's what we call an equivalent fraction. And even though they have different shapes, we know that these 4 blocks have the same size, so that means they are equal and equivalent. Now, is this model an equivalent fraction too? Stop and think. This is what we had before. Is this an equivalent fraction? Yes or no? What do you think? So let's go back for a second. We know that the size is the same, but the colors of the blue versus the red are not the same. So of course it would not be an equivalent fraction because in these two pictures, there's 1 block that's blue. Here there are 2, but there are a total of 4 blocks. So that's why it would not be an equivalent fraction. So we know that with pizza, I can draw a line down the middle and it is 1/2 of my pizza. Now, if I draw these 3 lines to make 4 slices, what do you think, to make an equal part, what do you think of the fraction that it would be to make a equal part? So I have 4 over here. What do you think? Take a moment. I know if I were to draw 4 slices over on this side, I have to have 4 slices on that side because that's what would make it equal. So we know that 1/2 is equal to 1, 2, 3, 4 out of 8 slices. So this is 1/2, but we know if we break it into 4 slices over here, we need to have 4 slices on the other side to make it an equivalent fraction. So now let's label what fraction of the figure is shaded, and we're going to circle which ones are equal. So which ones have the same size, the same number that are shaded. So take a moment, look through, pause the video, and try to figure out which ones are equal and what the fraction is. So for our first one, I know 1, 2, 3 out of 5, so 3/5 is my first fraction, or my first shape for my first fraction. Next, again, 3/5. The blocks are all the same in different orders, in different shapes, but the size of the blocks don't change. So 3/5 would be my fraction. Over here, I see 2 that are shaded out of 5, so 2/5, and 3, again, 3/5. So 3 are shaded out of 5 total blocks. Now, I have to circle the fractions that are equal. So 3/5 right here, 3/5 right there, and again, 3/5 right there, because we know that the blocks I'm measuring by the same size, and they're all equal to 3/5. So we know with equivalent fractions, let me move this up here, we know that they have to have the same size and amount. They are equal, right? We want to make sure that we're looking at the size and the shape because that will make it the equivalent fraction. So I have my number line over here at 0. I have 0/4 or 0/8. I break it into fourths first, then I break this 1/4 into half again. So now I have 8 total pieces to make 0/8, 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, 7/8, 8/8, which is also equal to 4/4. So if I have 4 pieces, I can break each piece into half and we get 8ths. Now we're going to move on to lesson 21, and this is being able to recognize and show that equivalent fractions refer to the same point on a number line, just like we had our number line on the slide before. We have it now. So let's look first. Can you find the equivalent fraction? Can you try to find a rule? So I'm going to take a moment. You pause this video, and we are going to see what the rule is. So I see my shape over here, and I have 3 shaded out of 4, which is given to us. And now if I break that into half, I have 1, 2, 3, 4, 5, 6 out of 8 pieces. So I would do 6/8. Look at this over here. I have 4/6. So I have 1, 2, 3, 4, 5, 6 pieces, and I have 3 over here. Is there a rule that you can find? And I know 2 are shaded in this one. Next, I have 1/2, and I have to count all my shaded parts. So 1, 2, 3, 4, 5 out of, if I know 5 are on this side, I know 5 are on the other side. So there are a total of 10, which is given to us. So I know this one is 5/10. Pause the video for a second. Think about if you can look at the 2 fractions. So I have 1/2 is equal to 5/10. A 4/6 is equal to 2/3. I have 3/4 is equal to 6/8. Can you find a rule? If you can, if you figured it out, let's keep going. Here is our trick. So there's a big trick to finding equivalent fractions. So to find an equivalent fraction, you need to multiply the top and the bottom by the same number. So we have the numerator and the denominator with the same number. So over here, my example is 3/5. So I need to go directly across 3 times 2 because I want to double it. 3 times 2 equals 6. 5 times 2 equals 10. So we know that 3/5 is equal to 6/10. Or if we have to divide and make it smaller, we have to divide the numerator and denominator by the same number. So we have 4/6, and again, I want to break it in half because 4, we need to think about the factors that we can use to multiply together. So 4 divided by 2 is 2, 6 divided by 2 is 3, and we know 4/6 is equal to 2/3. So no matter what, when you are multiplying and dividing our fractions to find an equivalent fraction, no matter what, this second number right here, this fraction, if it's by 2 or 3 or 4, whatever the number is, the numerator and the denominator must be the same. Because if I were 2 times 3 times 2, which is 6, and then 5 times 3 equals 15, that wouldn't give me the correct fraction. So whatever it is, whether you're multiplying or dividing, the numerator and denominator must be the same number, okay? So let's try it out over here. So take a moment, pause the screen, and think about if you can solve using our, let's go back to our last slide, using our trick, okay? Think about how we need to use the same number on the top and the bottom, same number on top and bottom here. So as we're going through, think about if you can solve this. Take a moment. I see that 12 is my denominator, and I have to go to 6. So would I multiply or divide? Is my number getting bigger or is it getting smaller? So take a moment, try to solve some of these, and then check your work with our video. So I have to think, okay, I go from 12, divide it into 2 to get 6, because I know 6 times 2 is 12. right? So if you're not sure about division, think about how you can change it into a multiplication. So 6 times something equals 12. 6 times 2. Okay. So now if I do 6 times 2, I need to do 6 divided by 2 on the top, which is 3. Next, I have 1/3. And I go from 3 to 6. I see this is getting bigger. So I'm going to try doubling it. So timesing it by 2. So 3 times 2 is 6. And 1 times 2 is 2. Next, I have 6 times, I see the 6 and the 12. So I know I have to get bigger. So 6 times 2 is 12. And 1 times 2 is 2. Over here, I see that my first fraction is a bit bigger, and I need to divide it and make it a little bit smaller. This one's a bit tricky. So I can't, wait a minute, 10 divided by nothing equals 6. So what can I do? If you need to, you can draw a picture and think about what 5/10 would be. What is 5/10? So, I know that 10 divided by 2 is 5. So 6 divided by 2 is 3. So if you can't divide this way, you want to make sure you're still using the same tricks for what you did before, what you used before, whether you're going left to right or top to bottom. So our next one, I see this is getting a bit bigger. So 3 times 3 is 9. 2 times 3 is 6. Great. 4 times, again, this is a tricky one. Same with letter G. 4 times nothing equals 6. And 2 times, I don't know this one up here. So I have to stop and think, okay. All right, can I go up and down? So 2 out of 4, that's half, right? If I were to draw a picture, I drew a circle, I shade in 2, I see that half of my picture, half of my circle is drawn in and shaded. So what is half with my denominator of 6? So if you need to, draw a circle, have 6 parts, and think, okay, what is half of it? So I can think 3. All right. So if I need to, I can do 4. 2 times 2 is 4, or 3 times 2 is 6. So as you're going through, friends, today for math, your job is going to be to think about our equivalent fractions. Think about using our trick, using our hints, whether you're multiplying or dividing, and making sure that equivalent fractions, if it's not the same shape and the same size, the shape, when you draw it out, may be different and organized in a different way, but if it's not the same size, that is where it's going to be a bit tricky, because then it won't be an equivalent fraction. So we want to make sure it's the same size and the same shape, because then that way you can really tell it is an equivalent fraction if you're using the same blocks to measure it out. All right, so today the secret word is rain. And if you have any questions, please reach out to your teacher. All right, happy